It's an old saying that a model railway can be finished, but it's never completed. Perhaps that's part of the hobby's attraction. It's certainly true of Bob Tivendale's Wheel Louise layout, one of the classic examples of the modeller's craft. It's surprising how many people derive immense pleasure and inspiration from layouts like this, and yet somehow never get round to having a go themselves. At heart, railway modelling is a practical pastime. And layouts like this and Bob's other layout, Ashley Bridge, are within the capabilities of anyone with the commitment and the knowledge. Even accomplished modellers like Bob have to begin somewhere, and for most people, the first question is where to locate the layout. At Peakorama in Devon is the living proof that everyone has the space for a model railway. For example, those who are lucky enough to own a loft have a huge space sitting literally under their own roof. For those of us who are less fortunate, a bedroom location offers possibilities. It's surprising how much can be fitted along one or more walls. This large G-scale layout may seem out of the question for most of us, but in point of fact, it could be fitted into any standard size garage. A garden shed offers similar potential, with the added attraction of possible future extension into the garden. Even someone living in a one-bedroom flat with no spare wall space has room for a layout. This model is about the size of a fish tank. Or what about a layout in a cupboard that folds away when not in use? Or perhaps a shelf layout in the hallway or living room. It can positively enhance the appearance and individuality of any home. Although not everyone may choose to run his trains as fast as this, everyone does have the room for a model railway. In this program, we shall be looking in detail at the construction of Axmouth, a compact layout and an ideal beginner's project. We'll go on to look at how the basic constructional methods can be applied on more sophisticated layouts. So let's get to work on Axmouth. The first question is what scale to work in. By going for N gauge at 2 1/16 millimeters to each foot, one of the smallest scales, we could squeeze in a lot more railway. Or one of the larger scales, such as the 7 millimeter to the foot gauge O, would give us less running distance but a lot more detail. Double O gauge at 4 millimeters to the foot falls roughly in the middle, and this is what we've opted for. However, all the techniques we'll be demonstrating apply equally to any gauge and any size of layout. To begin with, it pays to experiment by drawing rough block plans, showing the general arrangement of the layout. The available space can be used in different ways, for example, an end-to-end layout, or a continuous run, or a station-to-fiddle yard design. A fiddle yard is a set of hidden sidings representing the rest of the country where trains can be remarshalled before returning into the area depicted in the model. Many beginners automatically assume a layout has to be mounted on a solid baseboard, but a design with a central operating well can offer several advantages. By permitting the operator to see only part of the layout at a time, it creates a sense of reality. Trains actually seem to go somewhere. Also, it avoids problems when a derailment occurs at the back of the baseboard. Having arrived at a satisfactory arrangement, in our case a continuous run with 2 stations and a central operating well, it's time for some detailed planning. By producing a scale drawing in which 1 inch equals a foot, we can test whether our ideas will work in practice. It's not as awesome as it sounds. All that's needed is pencil and rubber, a ruler, a pair of compasses, and some graph paper. For our Axmouth layout, we have a modest space of 6'6" by 4 feet. Therefore, it will be necessary to use sharp radius curves. Even so, 15 inches should be the minimum. For a larger layout, we would be aiming at a radius of not less than 2 feet. Clearances and inclines also need thought. It may look good on paper, but if it means that trains will have to climb 3 inches over a gradient that's only 12 inches long, it simply isn't going to work. We'll be taking a closer look at gradients and multi-level tracks later. And what about train lengths? In double O gauge, we need to allow at least 1 foot per coach. The nice thing about producing a drawing is that you can erase and redesign to your heart's content. Better to waste paper than precious time and materials at the construction stage. Our Axmouth plan is in fact taken from the SETRAC plan book published by Pico. It's one of many sources of track plans available from Pico, which can be copied direct, or using methods we've just discussed, modified to suit personal requirements. Before getting down to construction, we can save pounds in wasted timber by giving some thought to planning the baseboard. Simply place a sheet of tracing paper over the plan and draw in the lines of the framework, allowing at least 2 or 3 inches beyond the edge of the track. We can now work out how much wood we need to buy and how we're going to cut and assemble it. Planed 2-inch by 1-inch softwood timber is the best material for the framework, being easier to cut and drill and more affordable than hardwood. But when purchasing, make sure you select straight, unwarped lengths. The golden rule is, let the frame take the strain. The top surface is simply there to support the tracks and the scenery. It should not be looked upon to provide constructional strength, and unless it's properly braced, it will warp after a period of time, and this could destroy a lot of work put into the scenery and other details. The framework should be designed so that no more than 1 foot is allowed in any direction without bracing. By staggering the bracing, it's possible to use simple butt joints. However, halving joints provide greater strength, and as they involve only elementary carpentry skills, we're going to use them for our baseboard. When marking up the timber, carefully measure out the positions of the joints along its length. Careful measuring is essential if both halves of the joint are to match accurately. A useful motto to remember is, measure twice, cut once. When measuring the depth of the joint, always be sure to use a rule to establish the center line. Another essential is the use of a set square to ensure that the cutting lines are at right angles. The width of the joint can be determined by positioning an offcut of identical timber along the first vertical cutting line and using a square to draw the final line. The original lines can then be extended across all sides of the timber. All joints should be marked up in the same way before commencing sawing. In addition to making cuts along the 2 edges of each joint, a third vertical cut is made in the center. This makes it easier to chisel out the unwanted waste timber. With all the joints for the cross-bracing cut out, we come to the corner joints of the outer framework. Following lines marked up in the same way as before, we simply need to make 2 cuts. At a later stage, we will want to run our wiring beneath the baseboard surface. Since it's difficult to foresee exactly what wiring will be required, it's advisable to cut a series of small slots in the surface of the cross members, so that wires can be threaded through when the time comes. With all the timber cut, it pays to loose assemble the framework before joining to check that all the pieces fit. To join the sections together, we need plenty of 2-inch number 8 countersunk screws, a suitable adhesive, and a set of bits for drilling. The first step is to prepare the holes. 3 types of holes should be made for each joint, beginning with a pilot hole, which is drilled into both matching halves. When this has been drilled, a clearance hole is made in the upper half of the joint. And to ensure a neat finish, we use a countersink bit so that the screw head will not protrude. In addition to screwing, each joint should be glued with a suitable adhesive such as PVA. Finally, the joint is screwed together. Excess glue, squeezed out by the pressure of the screw, is wiped away at the end. As each joint is assembled, the framework starts to take shape, and we're now ready to fix the baseboard top. At this point, two words spring to many people's minds, namely chipboard and hardboard. In fact, it's hard to think of less suitable materials. Try pushing a pin into chipboard and you'll see why. The most suitable baseboard surface material is Sundealer. It has closer fibres than ordinary insulation board and is therefore less easily damaged. At the same time, it accepts pins easily without any danger of them working loose. Sundealer is much lighter than hardboards and chipboard and, as a bonus, acts as a sound insulator. It's easier to cut as well. So, using a fine-tooth panel saw, we have no trouble removing the central operating well from a solid sheet of board. It's just a matter of scoring away at the surface to make a slit and then sawing out the required shape. The baseboard surface can now be attached to its frame. This is done by pinning and gluing it every few inches to the outer rectangle and cross bracing. When this task is complete, we are ready to construct a system of support for our baseboard. Models generally look better when viewed at eye level, so an ideal height is around 3 foot 6 inches. For the legs, 2-inch square timber works well. The main legs, conveniently fitted in the corner, should be complemented by secondary legs halfway along the length, with all joints screwed and glued from each side. We now have a solid structure, but what of its appearance? Strips of Sundealer provide a quick and inexpensive way to dress up the baseboard edges. They can be attached to the baseboard so that they cover both the framework and the edge of the baseboard surface. The Sundealer can be shaped so that it extends above the baseboard top, representing a profile for hills and cuttings, which will be added at the scenery stage. It can also protrude downward by approximately 1.5 inches to act as a pelmet for curtains, which can be fitted later to give the layout a neat and tidy finish. Our layout is beginning to take a little shape, and we are now ready to arrange the track work. There are two basic types of track: sectional track, similar to that which comes with a train set, and flexible track, which beginners usually progress to as they gain experience. Pico's set track, designed to the standard British geometry, is completely compatible with Pico's streamline, enabling modelers to make this natural progression without having to replace large amounts of track work at one time. In building the axe mouth layout, we are going to use Pico set track. The first step is to lay the track temporarily on the baseboard without fixing it in position or using any ballast underlay. The space between the tracks, known as the 6-foot way, can easily be established using the handy 6-foot way gauge available from Pico. When satisfied that the layout is correct, the next stage is to pencil in a line along each side of the track. As our layout will include landscape modelling, we don't fix down the track at the early stages, since no matter how conscientiously you go about building scenery, you're bound to spill some mess on the track work, which will prove impossible to clean and will interfere with the smooth running of the locomotives. Therefore, having marked the position of the track, we remove it so that we can get on with the landscape modelling. Bob Tivendale's Wheel Louise layout is an outstanding example of modelling, combining realism with attention to detail. The landscape has been constructed using the same basic principles that we shall be looking at, although like most modellers, he has modified them to suit his own needs as experience has grown.
It's based on a typical Cornish tin mine. This particular setup is a compromise because they were very extensive workings, and this is just to give an idea of the different processes that were used to extract tin from all the waste material that was lifted from the ground. It's all built on a base of expanded polystyrene, which is then covered with plaster, or a mix of polyfiller in fact. And then the grass that's stuck onto that is in fact surgical lint, stuck fluffy side down, and then when the adhesive's set, the backing's just ripped off, which leaves this sort of fluffy appearance like that, which is just sprayed with an airbrush with a variety of green paint. What I do is mix some brown powder colour paint into the white plaster so that if it does get chipped or knocked at all, it's not readily noticeable. But all the rest of the undergrowth is a mixture of proprietary things. There's woodland scenics material and rubberised horsehair, and we've got some etched bracken and foxgloves and various other weeds growing in amongst it all as well.
Like Bob, our task is to produce a representation of reality. So whilst everything will be condensed, it gains realism from remaining faithful to the basic principles of the prototype. For example, on Bob Tivendale's other layout, Ashley Bridge, he has created a farm and village section. It's striking for its realism, achieved mainly through a fine eye for detail. The farmhouse was in fact based on Bob's own house, and it demonstrates how observation of the real thing lends an air of authenticity to a model.
Study photographs, study the world around outside, and try not to get too complicated with things really, keep it simple. Keep the colours down, keep the greens towards a sort of yellow rather than the blue end of the sort of colour spectrum.
On a model, of course, the landscape is designed round the railway, but it should appear that the opposite has happened. Similarly, a flat area of land is, in the real world, anything but flat. As Bob has reminded us, a coat of green paint on the baseboard hardly resembles reality. The number of techniques to choose from is virtually endless. However, two techniques, namely built-up scenery and the plaster system, are popular and achieve very impressive effects. The term built-up scenery really covers a range of techniques, and most of which are particularly suited to reproducing rocky surfaces. For example, readily available natural substances such as stone or bark can be blended in with the scenery. Here is a chunk of bark, which could be purchased from any good model shop. We can see how it's been joined with plaster to make a very convincing rock formation. And the addition of some colouring transforms it yet again. This would make a pleasing landscape feature on any layout. Stones, of course, can be obtained from any garden at no cost at all. But when located on a model with the aid of a little plaster, the effect can look $1 million. Another built-up scenery technique is the use of polystyrene sheets. They can be built up in layers to the slope required and then shaped with a hacksaw blade. A polyfiller equivalent is then pasted on the surface and painted using watercolours. Now for the plaster system. Plaster can be used to represent virtually any type of landscape. As always, the base comes first. Because plaster is so versatile, almost anything can be used. One method is to use offcuts of sundealer. These make excellent formers over which we can stretch chicken wire, which provides a strong but flexible base for the plaster. The chicken wire is easily stapled to the sundealer formers. As an alternative to chicken wire, many modellers prefer to use strips of card. The card can be cut from old boxes, making this a very economical method. Interweaving the card before pinning it to the formers ensures adequate structural strength. Another good base material is polystyrene. Light in weight and easy to cut, it lends itself to being carved into the desired shape. It can be readily purchased from DIY stores, or, to minimise cost, obtained from discarded packaging. Just as with the rock face we looked at earlier, the polystyrene is built up in layers and glued one on top of the other using a standard woodwork adhesive. Now we're ready to mix the plaster. A domestic crack filler such as polyfiller is ideal. It should be mixed until it has reached a creamy paste consistency. Where we have a chicken wire or card base, the first stage in the process is to cut sheets of paper, or if you prefer, old newspaper, into convenient strips. These are liberally covered in the plaster paste and then laid onto the base. Be sure to overlap the strips in both directions. As the paste dries, the paper hardens, so that before long we have a solid surface. With so much messy paste splashing about, we can now see why, tedious though it may have seemed at the time, removing the track work earlier was a wise precaution. Finally, a second and even possibly a third coat of plaster is applied to the solid base with a brush to give sufficient strength. In the case of a polystyrene base, the layers of plaster can be applied without the need for newspaper strips. A palette knife is a most useful tool for applying plaster. It's quite a good idea to add some brown powder paint to the mixture, so that if at a later stage the plaster gets chipped, it will not show white. And for getting a smooth finish, there's nothing better than a wet paintbrush. On our axe mouth layout, card strips, chicken wire and polystyrene have all been used as a base for the plaster. With all the plaster now applied, we can introduce rock formations into the basic landscape using the built-up scenery method we looked at before. Alternatively, we can raid the kitchen for some cooking foil. With the foil cut into squares, we roll it up into a tight ball. By opening it gently, so as not to flatten out the irregularities, we have created a very effective mould. We can use this mould by liberally applying a thick layer of plaster to it. For best results, apply the plaster to the dull side of the foil. The foil is then placed on the wet plaster face and pushed up gently against the surface so that its irregular contours are impressed on the wet plaster. When the plaster has set, we remove the foil, and what remains is a highly convincing rock face. This can later be painted in appropriate colours and enhanced by the addition of various finishing touches. Before carrying out the finishing work, a coat of neutral primer is applied to the scenery to seal the plaster. The baseboard area around the tracks is also painted in readiness for the addition of texturing and colouring materials. Numerous finishing materials are readily available. Grass and general cover is best reproduced using one of the scatter materials. These come self-coloured and can, if desired, be blended in with water paint. The first step is to apply a coating of adhesive. PVA woodworking glue is once again the most suitable. This should be mixed 50-50 with water. The grass scatter material is then sprinkled over the adhesive to provide the basic foundation. However, the art of achieving a realistic finish is in the blending of the different colours. As we saw earlier, too much vivid colour is to be avoided. Suitable use of browns and other shadings enhances the overall impression and can be used to give emphasis to undulations. Remember, in addition to adding colour, we are also bringing textures to our scenery. Therefore, scatter materials are equally valuable in replacing the flat, one-colour appearance of the baseboard with a more convincing ground surface. As our scenery takes on a believable appearance, we can turn our attention to the roadway featured in the plan for our Axmouth layout. It's easy to think in terms of simply slapping some grey paint on, but as we can see from other modelers' layouts, texture makes all the difference. Again, it's attention to detail that makes the creative experience so rewarding. A thin application of plaster is a good way of introducing texture for roads, and we can work it in to develop the surface as we wish, even introducing a camber if appropriate. When it comes to painting the road, judicious use of shading can create effects such as tyre marks, increasing the overall subtlety of the model. And scatter materials can be used to add nice little touches, such as weeds growing by the roadside. They can also be sprinkled onto the surface as the paint is being applied. After the paint has dried, they will not only add texture, but also make the road look as if vehicles have actually driven on it. With the messy part of the scenery now complete, it's time to lay the track permanently. The set-track units are joined together using the fish plates already attached to the track. But before laying, a word about ballast. On real railways, the word ballast describes the stones that are packed between and under the sleepers to form a stable track bed. We are going to simulate this on our model by using the Pico Special Foam Ballast Underlay. Granular ballast can be used, but it's much more involved, and an example of this will be shown later. The foam ballast underlay is applied by just inserting the track into the slots created to take the sleepers. Using a sharp craft knife, the foam underlay is then cut to match the length of the section of track, and an impact adhesive is applied to the underside of the track. Only a little adhesive is required to achieve a strong bond between the track and the underlay. Once the foam has been glued to the track, another thin layer of adhesive is applied to the back of the underlay. When joining the sections of track, be careful to check that the rails are properly inserted in the fish plates. Some additional pinning may well be required, and the special Pico pins are available for this. Individual foam inlays are available for points and crossovers, and these are laid in the same way as straight track. Where a line diverges from a turnout, a neat join is achieved by trimming the ballast inlay with a sharp knife. When it comes to points, it's a lot more convenient to operate them electrically from a switchboard rather than by hand. Pico point motors are supplied specially for the job. They are designed to be attached to the underside of the points so that they don't spoil the appearance of the layout. Full instructions are given with each point motor, but fitting is straightforward, involving the use of simple tags to hold them in position. In order to accommodate the motor, we have cut a rectangular hole in the baseboard where points are to be located. The set-track points used in the construction of Axmouth are self-isolating. This means that the frog rails are electrically separated by a plastic tip. As a result, the track to which the point blades are set is electrically alive, with the other track being isolated. This is very convenient, for it means that locomotives or complete trains can be stored safely isolated in sidings, while train movements take place on the other road. The wiring required for the Axmouth layout is very straightforward, and a closer look at the plans will indicate where electrical breaks are necessary. It's quite feasible to operate the whole layout with one controller, but it does restrict some of the possible movements. Far more action can be had by electrically isolating each half of the layout and using a pair of matching controllers, one for each half. This not only enables two operators to work the layout, but provides a lot more movements. Trains can be offered from one section to the other simply by making sure that the matching controllers are first turned to the same position. Creating electrical sections sounds complicated, but in practice it's simply a matter of replacing the normal metal fish plates with Pico insulated fish plates. Being made of plastic, they prevent the current from passing through to the next section. A similar principle applies where it's desired to hold more than one locomotive or train in a siding. An electrical brake is made by inserting an isolating rail. A separate wire is connected to the rail on either side of the brake, and the two wires are fed to a switch. Depending on how it's set, the switch either allows current to pass across the gap or prevents it, in which case the end of the siding is isolated. The switch can be attached to the side of the track or wired into the central control panel. All wiring is, of course, laid so that it runs underneath the baseboard. We can now see the value of the slots we cut into the bracing when we constructed the baseboard. Careful routing and colour coding will enable wires to be readily traced in the event of a fault occurring. When connecting the underboard wiring to accessories, a good system is to use the so-called chocolate box connectors. Stocked by all electrical stores, they ensure neat and secure connections. The wires running from point motors can be connected at the other end to a variety of devices to permit operation. For example, a straightforward switch may be used. Or you can insert studs wired to the motor on a plan of the layout using an electrical probe to make contact and thereby set the road as required. Pico supply both methods of control. Bob Tivendale has built a quite complex control panel on his Ashley Bridge layout and finds this aspect of the hobby as absorbing as any.
The layout is basically divided into, can be run by from 4 different controllers. We use homemade handheld controllers like this. Each section can be plugged into one of 4. Rotary switches in the middle here. Each switch is for one section of the layout, which has 4 positions which control the different controllers. Indicators on the different track sections indicate which controller is switched in. The large push buttons operate the signals, which are all electrically operated. They are to a certain extent interlocked to the points, so you can't set conflicting signal and point movements. The points are worked by the lever frames at the top of the control panel. They are all operated by electric solenoids. It's all homemade except for the actual meters on the top here, and really from a large electronics supplier the basic components are comparatively cheap, and it's fairly straightforward to put them together.
Now that we have a working layout, we can go in to add the buildings and other railway features. Stations, perhaps, are the first priority. Platforms are available from the Setrak range in easy-to-assemble kits. Sections can be built up and added to produce any length required. Alternatively, the edging alone can be purchased and attached to plastic sheets cut to the required division. Buildings come basically in 2 varieties. Printed card with the windows and doors already punched out are quick to assemble and attractive, but all the detail is flat. Alternatively, there is a large variety of plastic moulded kits, the main components of which are moulded in appropriate colours. The detail is 3-dimensional, and a little additional painting, bringing out door handles and window sills, etc., will enhance the models and make them extremely attractive. In the various kits there will be everything you require, from line-side accessories and signal boxes to water cranes and coal staves. And then there are the people, available ready painted in moulded plastic or in white metal castings which are very detailed but have to be hand painted. A visit to your local model shop will inspire you to add endless details. One area not to be overlooked is signalling. In a small layout like Axmouth, most modelers add a few basic semaphore signals, such as starters at the end of the platform and so forth. If you are modelling current railway practice, there are, of course, colour light signals. These are permanently electrically alive and can be powered from your controller, although it's wise to use a separate source of supply. Another finishing touch is foliage. Excellent ready-made trees, hedgerows and bushes are available. The trees are fixed in position by drilling a small hole in the plaster and applying some impact adhesive to the stem. The hole ensures that the trees will withstand accidental knocking. foliage is simply glued in place. As with the grass earlier, a subtle blend of colours gives the most realistic effect. You can have a go at making your own trees. The basis for model trees is ordinary domestic wire, which is twisted and bent into an appropriate shape. A small vise is an invaluable aid, as manipulating the wire is definitely a two-handed job. With the basic structure formed, we can utilise the discarded cable covering to provide a basis for the trunk. This is strengthened and held in place by adhesive tape. Using very thin wire, again suitably twisted and bent, a network of branches is added. The thin wire is twisted into position on the basic structure and fanned out into a natural shape. Adhesive tape again provides solidity and holds the components together. Our tree is now taking on a recognizable appearance. That ubiquitous material, plaster, is now brought out again. This time it's applied over the tape to give substance to the trunk. When the plaster has dried, a quick going over with the paintbrush using a mixture of suitable colours finishes off the trunk. Leaves are easily added to the basic structure using lichen. This must be carefully teased open before gluing into position. The end result is soon ready to be placed on the layout. We must not forget the railway fence. With Pico flexible fencing, the posts are always vertical, even when going up or downhill. To populate the landscape, an endless variety of animals, carts and road vehicles is available. One final touch is the back seam. Hardboard or ply pinned and glued to the baseboard edge is the ideal method of support. Its height rather depends on the landscape, but to accommodate a back scene you need at least 9 inches. The Pico series of vaccine sheets, which should be pasted to the hardboard or ply support, includes a range of useful settings such as countryside, towns and docks. These vaccines are very versatile since each one will join to another in any formation. Our Axmouth layout is now complete, at least for the time being, and looks most impressive. So let's sit back and briefly enjoy the fruits of our work. One of the great things about railway modelling is that, as experience gradually develops, there are always new challenges. Braden is a similar sized layout to Axmouth. It's been built on a solid baseboard and is well within the financial scope of most modellers. It's a good example of how it's possible to progress without discarding all that went before. It is still built using Pico Cetrac, and yet it represents another level of sophistication. It has been ballasted with stone, and the scenic techniques have been more highly developed. So too has the layout's operation. Behind the station, out of sight under the hills, is a continuous fiddle yard, so that more than one train can be stored. Braden is not used as a continuous circle. Instead, trains come and go from either end of the station into the tunnel beyond, providing a deal of realistic operation for those watching. This layout has been exhibited at many exhibitions and won several awards for its excellence. Painstaking detail and creative development of the basic techniques we looked at earlier combine to evoke a truly lifelike atmosphere. The advancement from a beginner's layout, such as Axmouth, to the higher modelling standards illustrated by Braden is a part of the fascination of railway modelling that most of us experience in time. The work of master model maker Alan Downes is a long way from the simple kit-made buildings we looked at earlier. His Candleford Mill layout, which is on view at Peakorama, is an inspiration to us all. Buildings based on real-life prototypes are scratch-built and finished one brick at a time. And yet, daunting though it may seem to a beginner, it's possible to progress to these standards of workmanship. To demonstrate how the same basic techniques used on Axmouth form the platform for more ambitious projects, let's look at Chute Junction, a larger and more complex loft layout. We shall be looking at one section of this layout, with particular emphasis on creating 2 track levels and also this impressive canal. By referring to the block plan of the Chute Junction Railway, we see that this large layout is formed by smaller sections of baseboard buttered together. Each individual baseboard is constructed in the same manner as the earlier Axmouth layout. We now face the problem of joining our baseboards together. One solution is that adopted by Bob Tivendale on Wheel Louise. Bolts fitted at the end of each section enable the individual baseboards to be easily slotted together. Another solution is solid brass flap-back hinges screwed to the baseboard sections to provide perfect alignment. However, the original pin must be replaced with a longer one so that it can be easily removed when the baseboards are required to be separated. Now for different track levels. To ensure that the start of the gradient is not sudden or angular, the baseboard top is slit with a hacksaw blade each side of the section to be raised. We then cut supporting piers from offcuts of timber to the various heights required. Using the now familiar woodworking adhesive, the piers are glued and the sundealer is gently curved, ready for the support to be slid underneath. Finally, for extra strength, the sundealer should be pinned to the pier. We can see that the gradient begins smoothly, thereby avoiding awkward ridges that would be certain to cause derailments. This principle can be enlarged upon on the canal section of the Chute Junction layout. Instead of using a solid baseboard top, what is known as open-top construction has been employed. This method provides surfacing over the track-carrying areas only. The gaps in between will be filled in with scenery later, with the advantage that we will be free to construct scenery below track level. Plywood strips are pinned to the framework to provide a base. Piers to support gradients and elevated tracks are built up from the plywood using 2x1 timber and sundealer. Where curves are needed, a tiny subframe of half-inch square timber can be laid. Unlike solid timber, this can easily be formed into a curve, thereby eliminating any complicated jigsawing. With the basic open-top structure in place, the sundealer running surfaces can be located over the subframe. Blocks of 2x1 are attached to it to fit between the supporting timber already laid. In addition to gluing, the sundealer is, as always, pinned down. When working with multiple levels, be careful to ensure that there is sufficient clearance where tracks will be passing under high-level sections. Where clearance is not quite adequate, a strip of hardwood can be used to carry the tracks over the gap. Another refinement found on Chute Junction is that it uses Pico Universal's streamline track and point work. This flexible track, supplied in yard lengths, enables us to design more realistic curves and varied track layouts in any way we choose. Just as when using set-track, it's important to mark out where the track will go and defer the final track laying until after the scenery has been added. When marking out, ensure that the lines are about 2 inches apart, centre to centre, so that they conform with the width of the underlay. When using foam underlay, the technique is much the same as that used for laying set-track, but cutting and joining flexible track requires particular care. First, the section of sleepers adjacent to the joint is removed, so that the rails can be gently manipulated to temper their natural springiness. The sleepers are then replaced, being careful to ensure that the rails slot correctly into position. To allow the rail joiner, or fish plate, to be inserted, the last sleeper is cut free from the rail. Filing the rail ends ensures that the joint will be clean with good contact. Once the foam underlay has been added and the first length laid, using the same methods as with set-track, the adjoining rail length is marked up for cutting. On curved sections, one rail needs to be cut shorter than the other to achieve a butt joint. As with the first length of track, the adjoining rails are filed clean and the underlay added. Following this, the fish plates are inserted. The two lengths can then be joined together. In order to guarantee perfect electrical contact, the rail joiners form a tight fit, and therefore may not slide smoothly across the joint. A little assistance may have to be given using a small set of pliers. A device such as the Pico track setter is a handy way of ensuring the smoothness of the curves, and whilst gluing alone is sufficient on straight sections, some strategically placed pins are required on curves. Pico pins can be pushed through the track sleepers without making any previous hole by holding the pin with a pair of pliers near the pointed end. As an alternative to foam underlay, granular ballast can be liberally sprinkled between and around the sleepers. Any excess ballast should be brushed away to avoid unwanted particles getting into the mechanisms of the locomotives. Using a suitable container, preferably fitted with a spray nozzle, a fine film of water should be applied over the ballast. Then a small syringe should be filled with PVA glue, diluted 50-50 with water. The diluted glue can now be accurately applied. Once dry, the ballast sets hard. In addition to multi-levels and flexible track, another feature of the chute junction layout is the canal. There are many techniques that can be used to reproduce the effect of water. For stagnant water of the type found in a canal, a smooth and even surface is achieved through the use of a plain sheet of perspex. This should be painted on the underside to preserve the reflective appearance of the top surface and ensure that brush marks are not conspicuous. As with all scenic work, much of the effect is achieved through the blending of colours. In this case, a touch of yellow helps, but it should be merged in with the green to give a subtle rather than vivid effect. When the perspex is turned right way up, a pleasing impression of stagnant water begins to emerge. To complement this, the canal banks are easily made from shaped chipboard offcuts coated with paste and scatter materials in the same way as the scenery produced earlier. Running water can be represented using the technique employed by Bob Tivendale. Coat upon coat of varnish is built up to produce an uneven but glossy water-like appearance. Paint can be used to add shading and natural stones embedded in the varnish to add that final touch of conviction. An alternative way of modelling running water is our old standby plaster. By thickly applying it with a palette knife, we can create surface contours that resemble the patterns of flowing water. Once the surface has been created, the plaster can be suitably painted. As the paint goes on, the turbulence of the water becomes more visible and the overall effect can be further enhanced by mixing in areas of white paint while the original colour is still wet. This gives a good representation of form and brings the river to life. Finally, a coat of varnish over the entire surface ensures that our water looks forever wet. A large layout like Chute Junction gives a strong impression of depth and perspective. But there are ways of achieving similar effects, even on small layouts. Bob Tivendale, for example, has employed a technique known as low relief modelling.
The low relief model is a building that is modelled, it's basically just the front and anything up to, say, about a quarter of the depth of the building. There is no back to it at all. So all along the back here is what you would call a low relief model. It's a means of saving space without destroying the visual effect of the model. The models on this layout were built several years ago when I was using brick papers to finish them, which is a flat sort of a finish, but your standards are improving all the time. Modelling materials have improved considerably over recent years, and obviously when one is building models all the time with experience you get better, which is one reason why I shall eventually go across the whole layout, upgrading it in the smaller details and sort of general finish.
As we said right at the beginning, a model railway can be finished, but it is never completed. Some of the layouts featured in this programme can be visited at Peakorama at Beer in Devon. To be further inspired, see what other enthusiasts have done by reading Railway Modeller every month. This leading magazine caters for all those modelling the railways of Great Britain. If you model overseas railways, then you should read Continental Modeller every month. Meanwhile, welcome to the truly fascinating world of railway modelling. We hope that by demonstrating all the basic techniques and providing an insight into some of the more advanced methods, this program has encouraged you to get started.